So we'll understand one-tailed and two-tailed test with the help of this example. It says let's assume mu is the average grade point score of all the students in a state. We have taken a sample of say 15 students and now we are testing our hypothesis. So we will form the following null and alternate hypothesis and use the significance level as 0.05. So we'll first start with the right tail test, which says that our null hypothesis is mu less than or equal to 3 and our alternate hypothesis is mu greater than 3. So after forming the hypothesis, we will move to the next step. In this step, we'll calculate z-score, but since we are using a small sample size, so we will use the t-statistic here. We can calculate t-statistic by the formula shown here on the screen. Here x is the score, mu is the average score, s is standard deviation of the sample, and n is the sample size. Now this is only for demonstration purposes, so I am not going to show the calculation. I'll just assume that we have calculated t-statistic by using the above formula and it is coming out to be 2.5. So it's a simple formula, you just have to plug in the values and you will get the t-statistic. So let's proceed with the t-value of 2.5. So in the next step, we will find the p-value corresponding to t is equal to 2.5. We can use t-tables to find p-value just like we did in the previous section in the case of z-score. But that was only for demonstration purpose. In real life, all these things are done by a statistical software or online calculators. So you don't do it manually. Now let's say we got p-value is equal to 0.0127 by using an online calculator. So in an online calculator, we have to give t is equal to 2.5 and degree of freedom is equal to n minus 1, which is 15 minus 1 is equal to 14. We'll input these values and we'll get p-value is equal to 0.0127. Now in the next step, we'll compare our p-value with the alpha level and conclude on a null hypothesis. So here p-value is equal to 0.0127, which is less than alpha, that is 0.05. Hence we will reject the null hypothesis that our average mean is less than or equal to 3. So if you see on the right hand side, these things are shown on the curve. That is how we conduct right tail test. Now we'll see the second hypothesis, which says that average mean is greater than or equal to 3. So we'll again find the t-value using the formula as shown here. Let's just say that our t-value is equal to minus 1.5 this time. Actually the t-value would be minus 2.5 as the graph is symmetric, but I am just making up these numbers to show the procedure. So don't go by the numbers, just understand the process. Now we will find the p-value using t-value that we have calculated along with the degree of freedom, that is 14. We will give this value to any online calculator and we'll get the p-value as 0.0779. We can see here that our p-value is greater than alpha, hence we failed to reject the null hypothesis. So we can conclude that our average score is greater than or equal to 3. Now all these things are shown on the graph. So p is denoted by the red region and alpha is denoted by the hatched line. Now our red region, which is p, is crossing the alpha, which is denoted by hatched line. This means p is greater than alpha. Finally, we will see a two-tailed test. In this test, we will test if our mean is exactly equal to 3. So our p-value for a two-tailed test is always equal to 2 times the p-value of either of one-tailed test. So recall we found our p-value in the previous case as 0.0127. So for a two-tailed test, it will be multiplied by 2, which will be equal to 0.0254. Now when we will compare this with alpha, we find out that it is less than alpha, and hence we reject the null hypothesis. So that is how a two-tailed hypothesis test is done. But you might be wondering that how do we decide if the test is a two-tailed test or a one-tailed test? Many times in the problem itself, you have terms like greater than or at least, etc. So in such cases, you can easily decide what type of test it is. But many times you don't have this clear-cut information. So you decide it based on the problem. What you do is you choose a one-tailed test if you want to test the hypothesis in a certain direction. And you don't care if you fail to test it in the other direction. For example, you want to see if group A scores higher than group B. So the sole purpose of your study is to check this. And you are completely uninterested in checking the possibility of group A scoring lower than group B. So in such cases, we can straight away use one-tailed test. However, on the other hand, if you developed a drug that you claim is better than an existing drug, and if you opted for one-tailed test in this case, then you failed to test the possibility of the drug being less effective than the existing drug. Now in this case, there could be serious consequences. So if it is not given in the problem, then it is based on the judgment of the researcher. So that is how you decide whether it is a one-tailed test or a two-tailed test. Now again, the p-values and the alpha levels are shown on the graph. P-value is given by the red region and alpha values are given by the hatched lines. Now you can see the red region is not crossing the hatched line, which means our p-value is less than the alpha level. So that is how you conduct two-tailed test. Now guys, there is a good news as well as a bad news. The good news is whatever we have studied so far, it will all be done in R and we will not have to do all these steps manually. But the bad news is that real life scenarios are much more complicated and formation of null and alternate hypotheses requires some serious skills and experience. Now this skill is developed by experience only. It cannot be taught in a class or through a book. But there are certain foundational concepts so that you can apply it in the field and gain experience. But this is a skill that will come with time.